Okay, so this is week 5, and we have looked at order of operations, adding, subtracting sign numbers, multiplying, dividing sign numbers, fractions, ratio, percents, proportions, and we did talk about equations a little bit. And tonight we're going to go back and we're going to look at equations again. Okay, so hopefully it will feel better this time. Okay. All right. So the question is solving an equation. And we want to know, what is an equation? An equation says that two expressions are equal. Therefore, you must see an equal sign. An equation is like a balanced scale. Thus, you must practice the golden rule. What you do to one side, you must do to the other. An equation has 3 parts: the left side, the equal sign, and the right side. Now, the goal of solving an equation is to find out what the variable is equal to. And what the variable is equal to is said to be the solution to the equation. The solution to the equation makes the equation true. Okay. Now, when you finish solving an equation, it should have the variable on the left with a coefficient of 1, and it is equal to something else. Okay. And so that's the gist of solving an equation. And so we know that we have talked about SID: simplify, isolate, and divide. You have to simplify, meaning you have to remove parentheses, remove any fractions or decimals that you have, and add like terms on the same side. Once you do the simplifying, what has happened is that you've condensed what's on the left side and what's on the right side. Ideally, it's going to be down to two terms, and then you need to isolate. The variables go on one side, the numbers go on the other, and that probably will involve 2 steps. And then you divide. If the coefficient is not 1, we have to divide. Okay. Now, when we solve the equation, we either get a number, which is a solution. This is going to be what we call a conditional equation or a consistent equation. We could get no solution, which is the same as the empty set, or we can get all real numbers or infinitely many. Okay. So this is our first equation that we want to solve. And I have the directions up here. Let me see, can I move it? All right, so we want to simplify, which means remove the parentheses. We want to check to see if we have any fractions. And then the last part of simplify is to add like terms on the same side. So we do have some parentheses, and we need to remove the parentheses. In order to remove the parentheses, we're going to use the distributive property. The distributive property says I need to distribute everything to what's inside that parenthesis. So let's do that. So this is -3 times that -6. So a negative times a negative is a positive. So that's 18x. And then a -3 times 6 is a -18. Minus 2x equals 7 times x is 7x minus 7 times 4, which is 28, minus 2. So that's the first part of simplify. We have removed the parentheses. Okay. Now, we don't have any fractions or decimals, but we do have like terms on the same side. So on the left-hand side, 18x and minus 2x are called like terms, and we need to combine those. So that's 18 minus 2, which is 16x, and then I rewrite minus 18 equals. Now on the right-hand side, we have minus 28 and minus 2. Now, if you can't remember how to do that, I would change my signs if you can't remember that. So this is 7x minus 30. Okay, let me see if there are any questions about that. So we have condensed the left side and the right side down to a maximum of 2 terms. If you have more than 2 terms, you haven't finished simplifying. Okay, now that we have a maximum of 2 terms, we want to go to the next step, which says to isolate. Okay, the numbers have to be on one side and the variables have to be on the other. So let's focus on the variables first. So this is a variable and this is a variable. Okay, they have to be on the same side, so we need to get them together, and we do that by undoing. But before we do that, we want to take a look at their coefficient. This is 16 and this is 7. Okay, now typically you want the variables on the side with the higher coefficient. Now why do you want that? You want that so that the coefficient is not negative. It is okay if it's negative, but the fewer things you have to deal with, the better you come out getting the right answer. Okay, so if 16 had been over here, I would have just turned my equation around. Okay, so you'll see that I'll do one in which the variable is not higher, and you see that you get a negative coefficient. And when you have a negative coefficient, you just need to make sure you remember your sign numbers. It's not a problem, but if you can reduce some of the friction in solving the equation, do that. So 16 is higher. It is on the left. I'm fine with that. Okay. And so therefore, I'm going to put the variables on the left. So this is okay, and this is not okay. So since it is not okay, I need to subtract. Now, what I do to one side, I have to do to the other. That's called practicing the golden rule. After I perform the operation, I need to clean it up. So 16 minus 7 is 9x minus 18 equals negative 30. I have completed the first part of this. I have put the variables on the left. Now I need to put the numbers on the right. So this is 9x minus 18 equals negative 30. So this is not okay. And this is okay. So the one that's not okay needs to be removed. This is a minus 18. I have to undo that. To undo that, I do a plus 18, practice the golden rule. What I do to one side, I have to do to the other. 9x is equal to negative 12. And then finally, I need to divide. I don't want to know what 9 of those are equal to. I want to know what one of these is equal to. So I divide by 9. So x is equal to negative 12 ninths. Now I can reduce that. 3 are going to 12, negative 4. 3 are going to 9, 3. So the answer is negative 4/3. All right, questions about that? Any questions? All right. All right, let's try these two. All right, you try this one. See what you can do. Get it started, and then I'll come in behind you. So we'll take a minute to get started. Let's see. So we got 12 seconds. Okay. All right. So we want to simplify, which means we do need to remove the parentheses. So this is -3 times W is -3W. -3 times 5 is -15 plus 2 equals 4 times W is 4W. 4 times 2 gives us 8. So let's hopefully that you were able to get that first line. Now notice on the left side I have 3. I have 3 terms. So that lets me know I can combine something. Okay. So I can combine this and this. -15 plus 2 is a -13. Now that I have condensed the left and the right with a maximum of 2 terms, I am ready to isolate. I want to get the variables on one side and the numbers on the other. Now remember that I said we want the variables on the side with the higher coefficient. Okay. Now what I'm going to do this time is I'm not going to do it so that you can see what I'm talking about. See, these are my variables. Woof. All right, so let's do, there we go. All right, so this is -3 and 4W. See, 4 is higher than -3, okay? So ideally, I would turn this equation around so that 4 is on the left, but I'm not going to do it this time. I want you to see what happens and see what you like better, okay? I'm going to put the variables on the left, which is what we traditionally do. You don't have to, okay? So if I put the variables on the left, this is the screen wants to move. So this is okay. This is not. I need to move it off. All right, let me do this. All right, so this is -3W minus 13 equals 4W plus 8. And so I'm going to subtract this 4W from both sides. See, we end up with a negative coefficient, which is okay because we're smart, we can handle it. But like I said before, if you can reduce some of the stress and the friction, it's a better thing to do. Okay. All right. So now I'm going to put the numbers on the right. So this and this. So I'm going to add 13. -7W equals, this is 8 plus 13, which is 21. And then the final step is to divide by the coefficient of the variable, which is -7. And we get -3. Very good. All right, questions about that? All right, let's do this one. So we want to do the second one. All right, so we have to remove the parentheses. Let's do that. So that's 4x plus 4 plus x equals 5 times x minus 5 plus 9. So let me come over here. Okay. All right, on the left-hand side, I got 4x and x, that's 5x plus 4 equals. On the right-hand side, I have 5x plus 4. That's interesting, isn't it? What does this mean? So this, the left is identical to the right. So what does this mean? This is what it means. All right. So 1, the solution is all reals. And you can write the words. You can write this symbol. You can say infinitely many. Or you can do this. Now, what does it mean? It means any number will work. If you put any number into this equation, it will work. Okay. Now that's what the solution is. Okay. Now this equation also has a name. Okay. The name okay, and you'll see this if you take Math 114. These equations it has a name. This is what we call a dependent equation. Okay. The reason for that is because the solution is infinitely many. Okay. So it's called a dependent equation. And in Math 114, it's called the solution, the name of the equation is called a dependent equation. Okay. All right, let's try another one. That's the same one. No. All right. Do the first one for me. Let's see. Let me make this. That should help. Work out the first one. Yeah, these do confuse you. So as we go through them, hopefully it becomes clearer. Now this one is straightforward, and then we want to do this. Let's see. Then we want to do this one. We don't want to do this again. Let's see. Let's do this one. I'm sorry. Let's do these two. Hopefully it won't, Juan. I think that it's going to become clearer. Just hold on. Okay. So let's do the first one and the second one. Let me give you a few minutes to get started on the first one. So we have that's our equation. All right, so -2 times u is -2u. -2 times 6 is -12, plus 6u equals 4 times u, 4u, minus 4 times 3, which is 12. Everybody okay with that? All right, so these can be combined. 4u minus 12, 4u minus 12. Now, we saw this before. Now, what I want to do is to take this all the way out because sometimes students don't see it. And so what they'll do is that they'll just keep working. So I'll subtract 4u. And then I get -12 equals -12. That is true, but students keep working. And then they get to the point they can't do anything else. 0 equals 0, okay? Now, this is a true statement. When you work your equation down and get a true statement, that lets you know this is true, okay? But they didn't ask you if it was true. They asked you what is the solution, okay? So again, the solution is all reals or infinitely many. Now, let's do this so that you can see what I'm talking about. Okay, so I'm going to rewrite this. Let me clone this. All right, so what do we mean by infinitely many? Okay, so this is what we mean. Any number you tell me will work in this equation. So this is -2 and that's u plus 6 plus 6u equals 4 times u minus 3. Okay. All right. So let's take a look at what infinitely many means. All right. Infinitely many means any number I say u is will work. All right, let's come over here. I want u to be equal to 3. Okay. Now, the solution to an equation makes it true. So I'm going to draw a dividing line right here. And everywhere u is on the left, I'm going to put a 3. So -2 times 9 plus 18. -18 plus 18. I get 0 over here. Over here where u is, I'm going to put a 3. 4 times 0, 0. 0, 0. Okay. All right. Let's continue. All right. This time I want u to be 5. Okay. So let's let u be 5. -2 times 5 plus 6 plus 6 times 5. -2 times 11 plus 30. -22 plus 30. I get 8. Okay. Let's come over here. 4 times 5 minus 3. 4 times 2, I get 8. 8, 8, so it checks. If you want u to be 100, it will always check. This is what we mean by infinitely many. It doesn't matter. Any number will work. That's not the case with the other ones that we worked, okay? The other ones we worked came out with one solution. That's the only number that will work. With infinitely many, every number works, okay? Does that answer your question? So when we did this one, we got -4/3. -4/3 is the only thing that's going to work in this equation. With the last one that we work, any number we put in there will work, okay? All right, now let's work this last one, okay, right here. So this is -2 times w plus 1 plus 5w equals 3, w plus 1 minus 2. Okay? So let me see if I can condense this down. All right, let's work this one. All right. So -2 times w is -2w. -2 times 1 is -2 plus 5w equals 3 times w is 3w plus 3 times 1 is 3 minus 2. Okay. Now we have 3 terms over here, so that lets us know we can combine something. So 2w plus 5w is 3w minus 2. We've condensed it down to 2 terms. Let's come over here. 3w plus 1. Okay. So now I need to put the variables on one side and the numbers on the other. Okay. So I'm going to put my variables on the left. Now I want you to stay with me and watch what happens. So I subtract 3w and I get -2 equals 1. Okay. Now, we know that that's not true. Now, this is not true. Now, students often keep working. So if you add it to, you got 0 equals 3. If you subtracted 1, you got -3 equals 0. This is not true. And this is not true. So the question is, well, what is the solution? You probably already know. So if it's not true, can it have a solution? No. So the solution is no solution. Or you can write the empty set. Both of these, this is empty set, and this is the empty set. Okay. Now, the name of this equation is a contradiction. Okay. So you could have two types of equations. Now, okay, you can have a conditional equation or consistent equation. That means we have a solution. You can have a contradiction, or you can have that dependent solution. Okay. I'm trying to go to my chart. Oh, let's see. Okay, so here we are here. So if you get a solution, it's called a conditional equation or consistent system. If you don't have a solution, it's a contradiction or inconsistent system. If you get infinitely many like we did, this is an identity or dependent system. Okay, so this is what it looks like. Now, this is probably a good picture to take, and I'll stop and let you take a picture of that. And I'm going to take a so. All right. Any questions about that? So you can get a solution, no solution, or you can get infinitely many solutions. All right, let's look at an equation in which we have a fraction. And that's a decimal. And that's a fraction. So let's look at this decimal first. This is a real simple one. Let's just turn it around because we only have one variable. And so because we only have one variable, which is this, it's already on the left. So all we need to do is remove this. Okay. So we need to subtract 12.5 from both sides. So -7y equals, and that's -11.2. Okay. And so now we divide by -7 and y equals, now negative divided by negative is a positive. So let's see what this will give us. Okay, so we get 1.6. Questions about that? Questions about how we got the 1.6? All right, let's take a look at this. This is a fraction. And notice we haven't had any that have fractions in it, but this time we do. We don't have any parentheses, but we have fractions. So, all right, so how do we want to handle this? If you have a fraction in your problem, you want to get rid of it. Okay. Now, how do you get rid of it? Now, this is a simple one because you only have one denominator. And so to get rid of this fraction, we're going to multiply everything by this -8. Okay. Now, remember, this is an equation. So what you do to one side, you have to do to the other. Now, notice that on the left-hand side, I wrote this as a fraction. On the right-hand side, I didn't. The reason I wrote this as a fraction is because this is a fraction. I didn't write this as a fraction because it's in integer form. Okay, so you want to keep it balanced to make it easy. Now, we already know how to multiply fractions. This is a fraction. This is a fraction. If we can reduce along the diagonals, we need to do that. So these cancel. And we're left with x plus 42 over 1 equals negative times a negative is a positive. Now, x plus 42 over 1 is x plus 42. And so now we just solve this equation. Okay, so we need to just what? Subtract 42 and x equals 6. Okay, now we can check this. Let's check it. And this is how you check your equations, okay? So x plus 42 over -8 equals -6. All right, where the equal is, you draw a dividing line, okay? Because you can't cross the equal. Where x is, you put your solution. We said that the solution is 6. So I say 6 plus 42 over -8. Okay, 6 plus 42 is 48 over -8. 48 over -8 is -6. Over here is -6. That means that our solution is correct. Okay, that's how you check it. All right, questions? Any questions about solving your equation, removing the parentheses, putting them on the right side, what type of equation you get? Any questions? Now, I don't want you to freak out over this. These are what we call literal equations. They are literal because you got more than one variable. And I want to show you this is because when we get into graphing, you're going to have to solve for y, okay? And so I just wanted to show this to you so that when you see it, you won't freak out. We can solve for any variable that we want. We can have all variables here. It doesn't matter. The procedure is still the same. You have to focus on what you're solving for. So in this particular equation, I want to solve for y. Here is y. Whatever you're solving for has to be on the side by itself. It doesn't matter if it's a number, whatever. I am solving for y. So I have to have it on a side by itself. Now, currently, it's on the left side. So that's the side that I'm going to keep it on. So that means that this is not okay. Okay. I have to get it off. So therefore, I'm going to subtract 8x from both sides. When I do that, I get negative 5y equals negative 8x plus 9. Now, when you're dealing with literal equations, you won't be able to combine anything. That's okay. So I just want you to know that. We can't combine negative 8x and 9 because they are different. Okay? Now, once you get what you're solving for on one side, we know then that to be finished, the coefficient of what we're solving for has to be a 1. Now, this coefficient is a negative 5. So I need to divide everything by negative 5. So y equals, now negative divided by negative is a positive, 8/5 x minus 9/5. And we would leave this just like this. Okay, because in unit 7, we're going to graph this, and this is the form that we need to leave it in. Okay, so I just want to show this to you that it doesn't matter what we're solving for. For example, if I have box plus circle equals 11, and I told you to solve for box, okay, well, here is box. Box has to be on the side by itself. So circle has to move. So I would need to move this circle. I'm calling it a circle. So now I have box is equal to 11 minus circle. You see that? So it doesn't matter. This is whatever you're solving for has to be on the side by itself, and the coefficient has to be 1. And this coefficient is 1. Now, I could have had 3 boxes on the left, 3 boxes on the right, and ask you to solve for that. Okay. All right, let me stop and let you ask a few questions before we continue. Any questions? Okay, let's go to word problems, and we have to pay attention to keywords. So if we want to add, we're going to see the word add, more than, increase by, plus, and sum. Okay, these keywords mean to add. If we want to subtract, we're going to see the word subtract, minus, less, less than, diminish by, difference, decrease by. If we want to multiply, we're going to see times, multiplied by, product of, and twice. If I want quotient, I'm going to see the word quotient, divided by, divide, per, and ratio. Now, less and less than, they are different. If I say 4 less 3, I write 4 minus 3. If I want 4 less than 3, I have 3 minus 4. Okay, notice that less, you write what you see, and less than, it goes to the right of that number. So 4 less than 3, that would be 3 minus 4. Questions about that? Any questions? All right, so here's our first word problem, and I want you to read it at least 2 times before we get started. And this is just an expression. We're just trying to set it up. And when you can't see how to set it up, you want to draw a picture. It says we have 13 teams. So these are the 13 teams, and each team has K players. So if you can't figure it out, then you do it like that. So we want the total number of players. We can add all these up. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have 13 of these. 13 of these. And what are these? And this K. So 13 times K. So the total would be 13K. All right, let's ask a question about that. You're awfully quiet. So ask a question about how I got 13K. Does that make sense to you? Do a thumbs up, thumbs down, something. Oops. Okay. All right, let's look at this. It says translate into an algebraic expression. That's twice. Twice means 2 times. So that's 2b. All right, try that one. Jenny's score increased by 8 is 52. Now, this is a good one because we just, Jenny's score increased by 8 is 52. Now let's see, let's go back to our words. Okay, here it is. Increased by. Okay. Increased by means plus. So Jenny's score, they told us to use a J. Increased by is plus. 8 is the number 8. Is means equal and 52. So J plus 8 equals 52. That's how we would write that equation. Questions about that? All right. 47 less than. Let's go back to less than. Okay. 4 less than 3. So this number goes behind. Okay. So here we are. 47 less than twice a number. So we need to translate twice a number. Okay. So twice a number, and the number is n, is 2n. And we want 47 less than that. So that would be minus 47. 2n minus 47. Are we okay with that? Okay. here is an equation. So D equals RT. So D stands for distance. R equals rate. And T equals time. Okay. And so all we need to do is just fill in. So it says a tortoise is walking in the desert. It walks at a speed of 5 meters per minute. Now this is our rate. Okay. 5. For 156.25 meters, that's distance. And then it says, find how many minutes did it walk. So we need to find T. That's all you do. You read it and then you take each number and plug it in. So now I have D equals RT. What is D? 156.25 is equal to my rate is 5T. So that is my equation. Let's solve that. (156.25) equals 5T. I'm going to just turn this equation around. And we want to solve that. Solve that for me. Put it in your calculator. So let's see. If I divide it by 5, let's see what we get. So I get 31.25 minutes. Okay. All right, questions? All right, let's take a look at this equation. All right, we have what, about 7 minutes? Let's see if we can solve this quickly. And just put your answer in the chat. See if you can solve this. It's basically 2 steps. Okay, so solve this equation, even though it does have a fraction. Yes, I mean, that is true. Yeah, but once you get that, once you do that, it will become easier, okay? Because you know, you have to get acclimated to it. Okay, now this does have a fraction, but notice it only has one fraction. That's the only fraction in this problem. You only have one letter and the coefficient is 1. Okay, so we wouldn't get rid of the fractions here because we would be giving ourselves more work. But if we had 2 or 3 fractions, we would get rid of it. So the only thing we need to do here is subtract. And so this cancels. And so W equals -5 and 5, 6. And we would change this to improper. Okay, -35 over 6. Okay. All right, so let's see what we've talked about. We talked about solving an equation. We found out that we can get one of 3 answers. We can get a solution, and it's called a conditional or consistent. Let me see, can I find my chart? Okay, so we can have one of 2, one of 3. Here we go. All right, we could have no solution, which is also the empty set. Is called a contradiction or is an inconsistent system equation. Or we can get infinitely many. Infinitely many means that whatever number we want to put in it, it will work. Okay, so it's infinitely many, it's all reals. Um, this is an identity or it is a dependent equation, dependent system. And you can recognize it because it'll end up with a true statement. Okay, that's how you recognize it. If it ends up as a true statement, then it's infinitely many. If you end up with a false statement, then it's going to be the empty set. Okay. All right. Any questions about anything? So we just had solving these equations. We had some with fractions in them. We found out if we had, several fractions, you need to clear the fractions out. And if you just had one fraction and your variable had a coefficient of 1, then it was more work to multiply by the fraction than to just work it. Then we looked at the word problems, looked at these keywords. These words are important. And so you want to, this probably might be something that you might want to take a picture of as well. Add, more than, increase by, plus, sum, and subtract, times, quotient, less, and less than. Okay. So I would take a picture of this as well as the types of solutions that you can get. Any questions about anything? I'm sure you have to go back and think about this and then just post your questions in the discussions. That's fine. Any questions? Well, you said, I don't know what question to ask. I've been there too. You're doing great though. So I'm here, I wait, see if you have any questions that you need to ask, anyone that I need to go back over. We can do that as well. We can look at our literal equation, which we had more than one letter in the equation. Let's see, can we find that one? Like this one, okay? We had more than one letter. The goal always is to get what you're solving for on one side with a coefficient of 1, okay? Whatever you're solving for with an equation, it needs to be on a side by itself, and it has to have a coefficient of 1, okay? And I pointed this out is because we will be graphing. And so we need to know how to solve the equation for y. And while we're waiting, let me ask this question. We did the distance problem. So let's do this quickly. So if we wanted to solve for r, okay? See, this contains r. But now the coefficient of r is not a number this time, it's a letter, it's t. So to solve for r, I would need to divide by t. So d divided by t equals r. So that's how we work with letters. Keeping in mind, whatever you're solving for has to be on a side by itself. and the coefficient should be 1. That's always the key. It has to be on side by itself, and the coefficient should be 1. Okay. All right. Good enough. And I'm going to let you go and think about this and send me some questions. I'm going to stop the recorder